Here are your solutions to 4-1, the letter problems. In problem letter A, we're being asked the total cost of tickets to the school play is shown in the table. So one of the things we should notice right away is that we have T representing tickets and C representing the cost in dollars. And the next thing we ought to check is what is the change in Y, and the change in Y in every case is $4.50, 4.5, and the change in X is a +1. This is positive as well. So our change in Y over change in X is 4.5 over 1, we could call that. So we have Y equals mx plus b. So in order to try and determine what our b is, we can work backwards and subtract 450, and we end up at 0. If we work backwards and subtract 1, we also end up at 0. So we can see that our b value, our y-intercept, is going to be 0, so we don't have to write it. So it's a matter of y equals our slope, which is this right here, 4.5 times x. So we have an equation. The first thing they asked us was to write an equation to find the total cost of any number of tickets. So whatever number of tickets, now actually we could go back and we could change this because this is our output of, so this would be y, so we would say that the C, the cost, equals 4.5 times t, the input. These are the same equation, but this one here uses the variables that we had in the table. So there's our equation, and then describe the relationship in words. To describe this relationship in words, we would say that the cost of the tickets, C, is dependent on the number of tickets times 4.5. So in other words, 4.5 times the number of tickets will yield our cost. So now the last thing they ask us to do is use the equation to find the cost of 15 tickets. So we would have cost equals 4.5 times 15 tickets. Or we could have written it like this, which is what you oftentimes see. So we have 4.5 times 15 is $67. So C equals $67.50. That is how much 15 tickets will cost. Problem letter C, we are being asked the number of trees saved by recycling paper is shown. So at 1, we have 17 trees saved. So at 2 tons, we save 34 trees. 3 tons, we save 51 trees, etc. So it asks us to write an equation to find the total number of trees, Y, that can be saved for any number of tons of paper, X. So we have tons of paper. That's the change in X. Change in X. And this would be the change in Y, which would be trees saved. So we have the change in Y, which would be 34 minus 17, so that would be 17, over the change in X. 2 minus 1 would be 1. So we have a slope of 17. So it says write an equation to find the total number of trees, Y. So we're going to write Y equals, that can be saved for any number of tons of paper, X. So we're going to use an input of X, and we're going to use 17x. Now the one thing we need to verify here is that we do not have a y-intercept. So we can do the same thing we did here, 34 minus 17. We can go 17 minus 17 would be 0, so that's good. We're going to go through the origin in that case, and we also have 2 minus 1 is also 0. And actually you can take a look at this, and you can recognize that if we make a very straight line through all these points, we do indeed go right through the origin. Okay, so we have an equation of y equals 17x. The next thing that they ask you to do is to use the equation to find out how many trees could be saved if 500 tons of paper are recycled. So we have y equals 17x. We can y equals 17 times 500, which is y equals 8,500 and they ask us how many trees could be saved, so that is 8,500 trees. Okay, let's take a look at letter E. First of all, we have the statement, Paul earns $7.50 an hour while working at a grocery store. First of all, you should immediately think about $7.50 an hour as 7.5 times something in order to make an equation here. But let's take a look at this first. Letter E. Write an equation to find the amount of money Paul earned, M, for any number of hours, H. So obviously M, the money earned, is going to be our result. So M equals 7.5. You can add the 0 there if you want to remind yourself that we're talking about money here, times the number of hours will yield the amount of money he's going to make. So there's our equation. It's $7.50 times the hours equals the money he makes. Now it asks you to make a table to find his earnings if he works 5, 6, 7, or 8 hours. So remember that you skip the first set of boxes here, and we're going to put our 5, 6, 7, and 8. That is going to be our input. So our input obviously is hours. And then our algebraic expression here is going to be 7.5 times H. And then our output is going to be M, the money he makes. Okay, so let's finish this problem the easy way by plugging in our answers here. Recognize that in each case, what we did is we used our equation, 7.5 times the input of hours, and here's our inputs for hours, and that would give us our output for the amount of money that he would make. So we had 7.5 times 5 gave us 37.50, and then we plotted that point at 5, input of 5, output of 37 and 5/10, or 37.50. And then we plotted each of these points. 6.45 is right here, 7.52.50 is here, and 8.60 is here. So let's clear this so that we can see this a little bit better. And lastly, recognize that we need to label our input, which is always on the x-axis, of time, and most importantly, I want you to make sure you always put a unit. If you just put hours here, that would be fine with me. And then over here, we would want to make sure we put dollars so we recognize that we're graphing dollars. So they asked us to write an equation. We did that right here. Remember, always think of our output equals our slope times our input. And this is our output of money, is our slope, 7.5. That was our unit rate. That's why we know it's slope, times our input of hours. And then they asked us to make a table. We did that here. We included the values for 5, 6, 7, and 8. We put labels on it here, here and here. And then we used an algebraic expression in the middle where we actually do our calculation. And then lastly, they asked us to graph our ordered pairs, which we have right here. Now, sometimes you want to put a line on these, and sometimes you don't. For example, sometimes it makes sense. For example, we could have an input of 5.5 hours, but sometimes it would not make sense to have 5.5. So you have to think about whether or not you want to put a line on that. Thank you. Please complete the guided practice.